object-oriented programming. Do you know what it is or have you worked with it before? If not, follow along because we are going to apply it to our project right here. Instead of using arbitrary objects, we are going to work with concrete objects. Say for example, this piece is a concrete object, this position as well. This piece will accept some parameters and those parameters are getting passed on into the constructor of this piece. The piece has a constructor because it is a class. What we can do in a class is write logic. As you can see, the image of the piece is determined by the type and the theme of the piece. Instead of writing down all the images yourself, we are going to automate this. Want to know how? Follow along. Hello and welcome to part 25 of the series on how to create a chess game with ReactJS. In this part, we are going to start with applying an object-oriented approach to our project. If we open up the source folder and then go to the constants, we see that we have interfaces. Right here, we have the interface for the piece. Instead of creating an interface for the piece, we want to create a class for the piece. The reason why we want to create a class for the piece is because then we can start implementing logic inside of that class. Inside an interface, you cannot implement logic. An interface only states which variables or functions something exposes. So say, for example, this piece interface exposes a property named string or image, which is a string, a property named position, type, theme, and so on. We could also add a function to the interface, say for example, play move, which is a void. Then this piece would need to implement a function, which is play move. As you can see underneath here, we get a lot of errors because right here in the initial board state, we define that the initial board state is a piece array. Since it's a piece array, every element inside of this array must be of type piece. In this case, it must implement the interface for the piece. So that means that every property right here must be stated down here, but also the play move function must be implemented right here. So for now, we remove this. And once again, an interface is only a contract which tells you what properties or attributes or functions are exposed to the outside world, which talks to that interface. Normally, an interface is used with a class. A class implements the interface, so the class must oblique to the properties and the functions that the interface states, but the class can also provide its own parameters or its own attributes and functions which are not stated in the interface. And this creates the possibility to have a class which exposes some of its methods to the outside world. We call them public, and some of its methods and variables are not exposed to the outside world. We call them private. Enough talking about classes and interfaces, let's create one. Inside of our source folder, we are going to create a new folder named models. And inside this models folder, we are going to create a piece. We are going to name it piece.ts, and we are going to define our class. We will say export class piece, and then curly brace open, curly brace closed. And then we can define the properties of this piece, but we must also define a constructor. So here we say constructor. And this constructor is being called when you instantiate a new piece. So when you instantiate a new object of type piece. Right now the piece is empty, but we want to add the properties that we have right here inside of our piece. So we add them like this, and we immediately get some errors. Well, the first error is property image has no initializer and is not definitely assigned in the constructor. This means that the image is not being declared nullable, which means that a question mark is behind there. If there is no question mark behind the variable, it means that it must have a value. We do want to have a value for our image, so inside of our constructor, we need to say that this.image will be some value. So for example, we make it an empty string right now. The ampersand move right here doesn't have the error because it's optional. You don't need to pass it as a parameter, and we don't need to assign it inside of the constructor. We also get some errors for the position, the piece type, and the theme type. We can fix those by importing them from our constants, like so. And we also get some red squiggly lines. The same reason why we got them for the image. They are not nullable, so they cannot leave the constructor without having a value assigned. So let's say that this position is, and then a new position called 0, 0. The type will be piece type dot, and then we are going to make a pawn, and then the theme type will be theme type dot hour. We have now assigned the mandatory variables inside of a constructor, but if we create a piece, all the pieces that we are going to create will have no image, will have no position, will have the type of pawn, and will have a theme which is our theme. So say for example, if we create our pieces right here, the bottom line, all those pieces will have the same image, the same position, same piece type, and the same theme. And the same goes for the pieces on top right here. They will also have exactly the same variables. So how exactly can we modify those variables? Well, we can pass them in a constructor as parameters. So let's add those attributes as parameters. We will have an image, which will be a string, a position of type position. Then we will have a type piece type, and a theme of type theme type. And then instead of hard coding this to an empty string, we say that this.image is equal to the image that is being passed in a constructor. Same goes for the position. Position will be equal to the position we get in the constructor. The type will be equal to the type from the constructor, and the theme as well. Now we have a basic constructor for our piece. Let's use it. Let's save this up, and inside of our constants right here, instead of creating the piece array like this, we want to create the piece array based off our objects or our class. First of all, we are going to remove this interface. As you can see, we get an error right here. If we now import the piece model right here, we see that it is still working. Well, not exactly, because if we open up our chessboard, we also need to fix the reference. So right here, we don't need to import it from the constants anymore, but we need to import it from the models. Right here. Yes. Is there any other place that we have missed inside of our referee? Right here. We need to import the piece from the models, like so. And we might also need to import it inside the referee rules, I think. Yeah, so I will go over this quickly and I'll be back in a second. Alright, now that we fixed that, let's check if the game is still working. And it seems like it is, but instead of using an interface, we are using classes right now. So I'm just going to close up all the files that I just opened, and right here we are back at our piece. Okay, so the interesting thing right now is that we can start implementing logic inside of this piece. So right now, inside of the constants, we pass all these values to our piece. But the image consists of a link assets/images/piece type, which is the rook, and then the theme type, which is B or W. Instead of passing this as a string, we could also create this string based off the type and the theme that we pass on to our piece. So we're just going to copy over this, and inside of our piece.ts, let's put that right here. So right now we hardcode the image to be rook lowercase b, and if we save this up, we will see that, well, nothing really is changing. And the reason why is because we are not using the piece constructor yet. So right here, we are creating new pieces, but we don't call the constructor. What we want to do is we want to create, or we want to call the constructor of the piece class so that the values get set correctly. The first piece in this list is the rook. So instead of writing it like this, let's write new piece, and then we pass in an image, which will be this. And then the second parameter would be the position. So we say x, which is equal to 0, and y, which is equal to 7. Then the next thing will be the, let's say, the type. So this will be piece type dot rook. And then finally, we will have a theme, which will be theme type dot opponent. Now, if we remove this first rook and we put a comma behind here, we will now have one piece exactly, which is being constructed using the constructor instead of being constructed with an empty constructor and then being assigned all those values manually. Let's save this up, and if we refresh the page, we should still see our rook right here, still able to move, which is great. Instead of doing this only for the rook, we want to do this for all the pieces. I'm going to write this each on a new line, so it is clear. Let's do one more piece together. So the next piece will be the knight. We say new piece, then we copy over this image. Then we say position will be equal to x is 1 and y is equal to 7. We will have the piece type of knight. And then finally we will have a theme type of opponent. We can put a comma behind here, and we can remove the previous code for the knight. Now if we save this up and refresh the page, we see that we have two rooks. This is because before we have hard-coded this image to the rook image. So for now we are going to put image back, and we are going to comment out the rook image. If we refresh, we see the horse again. So that's still working. First, before we are going to work on the image, we are going to convert all the images or the pieces that we have right here into pieces which call the constructor. If you want to do this yourself, feel free to do so. But if you want to just copy over the new code, because it might be a little bit repetitive, you can also find the link in the description down below for the repository, where you can find the updated code, which will be available after this video. Alright, I have updated all the pieces to be to use the constructor instead of not using the constructor. Let's refresh the page, and right here we see that we still have all the pieces working normally, but now we have them as classes. The next thing that we want to do is, inside of this piece, we want to hard-code this image to the rook. So you might wonder, why are we going to do that? Well, I'm going to show you why. Because right now we have a lot of rooks, and a lot of rooks mean that you can, well, do a lot of things. But what is important is that we can put some logic inside of our piece. So because we made a class, we can put logic inside of that class. Before we had an interface, we couldn't do anything. We could not put any logic inside of the interface. Now that we have a class, we can put logic inside of it. So instead of using the logic of let's make every piece a rook, we are going to determine the image of the piece based on the type that gets passed in and the theme that gets passed in. So if we put a $sign right here, and instead of saying rook, we say type, and then let's leave the B for now. We can save this up and let's refresh the page and see what we have in our DOM tree. If we go to this tile right here, we see that it made the following URL: assets/images/tree lowercase b.png or underscore b.png. The type which we pass in right here is being converted to a number called 3, but we can change that. And this is where it gets interesting, because if we go to the constants any type, and we say that the type of pawn is equal to pawn, we also must give all the other types an initializer. By default, it is initialized by number. So here we have the rook, I think it was. Was it correct? Oh, on top right there, bottom left, yeah, that's the rook. So we say 0, 1, 2, 3, 4, 5. So the pawn would probably have an index of 0. If we go to this tile, we see a 0. The bishop will have an index of 1, knight of 2, rook 3, queen 4, and king 5. But we can change that. Instead of using numbers to identify the enum, we can also use a string. So right here, we give the identifier of the pawn, pawn. For the bishop, the knight, the rook, queen will be queen, obviously, and then finally the king will also be a king. If we save this up and refresh the page, we see that we have exactly the same thing as before, but now it's all black. If we go to our piece, we see that we use the type as a parameter or as a variable, but it's still hard-coded to B. Well, we can change this as well. So if we put a $sign right here and then say theme, we can open up our inspector again. And what do you think that will appear on the source of the image right now? All right, we are going to select the rook on the bottom left again. And here we have assets/images/rook/ or underscore 1.png. So here we have the white rook, and on the top we have the black rook. Let's see what the order is of our theme type enum. Opponent is 0 and our is 1. So it makes sense that there is a 1 right here. If we go to the top, we see that there is a 0 right there. Well, just like the piece type enum, we can change this to B and this to W. And now if we save this up, refresh the page, we see that we have exactly the same board as before, but instead of passing the image as a string, we can remove it right here. We determine the image based off the type and the theme that gets passed to the constructor. I'm going to format this a little bit different, like so, and save this up. And once again, the important difference between a class and an interface is that the class can contain logic. So right now we are determining the image based off the theme type and the piece type. This wasn't possible before because you can't do such a thing in an interface. Okay, so right here we don't need to pass the images as parameters anymore. So I'm going to do a cheeky little shortcut right here, which is Ctrl D. We select the next occurrence. And so I can select all the assets or all the occurrences of assets. And now that we have all the assets selected, we can press the left arrow key and the left arrow key again, press Ctrl and Shift and the right arrow key, press the right arrow key again until we have selected this whole string with the comma. And now we press delete. So now we have deleted all the images from all the pieces. Instead of going over one by one, we can do it just in one go, which leaves, which improves our performance, and well, it saves time. Let's save this up, refresh the page. We should see that it works. So let's save it up again. Maybe it didn't compile correctly. Yeah, so now it did compile correctly. And we see that we still have our pieces and the enemy pieces as well. One thing I would like to add to why we are doing this is because in the future, if we want to add more logic to our piece, which we are going to, we can do that with the class. If we were to use an interface, which we did before, we couldn't implement any logic onto our piece. So this part, this object-oriented approach, is really crucial for the game because we can encapsulate the logic in the object or the entity, the class itself. So instead of putting the logic outside of the class, we put it inside the class. So we get smart pieces instead of dumb pieces. For now, we are going to do the same with the position. So here we say position.ts. We're going to say export position or export class position. And this position will have a constructor. And it will also have two properties, which will be the x and the y. So right here, we're going to copy over the x and the y. And they are mandatory, so we get the red squiggly line again. And inside of the constructor, we are going to assign them values. So first off, we want them as parameters. X, which will be a number, and y, which will be a number. And then right here, we say this.x is equal to x, and this.y is equal to y. So now we have made a class out of our position interface. Let's save this up. And instead of the constants, well, we already use it. If we save this up, we might get an error. We don't, because the interface still exists. So we are going to remove that next. If we save this up, then we should get some errors. Yeah, exactly. So it doesn't recognize the position anymore. Well, that's fine. We can import it from the models. And it will probably also appear on the chessboard, where we are right now, but also on the referee, I guess. Oh, we can't import it from the piece models. So we are going to say position like so. The referee right here. And then probably also all the referee rules. No, we don't want to use Emmet. Okay, a quick thing we are going to do as well is we are going to make an index.ts. So right here, we're going to say index.ts. And just like what we do right here with the rules, we export them like so. We are going to do the same for the piece and the position. So we are going to say export that as from, and then dot slash piece, and then the same export star from dot slash position, like so. No, this needs to appear behind there. Well, we still get an error for the piece. That's because the position is not in a constants anymore. Let's remove that. We can re-import it again from dot slash position. But now if we go inside of our referee, we should be able to not import them from model slash piece and model slash position, but just from models. That was not where I was going. Let's go back to the chessboard. We are not going to import them from model slash piece, but just from models. So that should work, right? We don't get an error. And then instead of importing the position separately, we can import that one from the models as well. So now we keep everything under one namespace or one file or module, as you would call it, named models. So I'm quickly going to do this for the referee as well. going to remove the piece right here and put position behind here. Next I'm going to fix the rules one by one. I'll be back in a second. Okay, I fixed all the reference errors. Let's try and move our pieces once again. Let's see, we can still move the queen, the pawns, enemy pawns, queens, rooks. Yeah, okay, seems to be working. What did we do? We have created a class for the piece and a class for the position. The piece now has some logic right here, which we couldn't do before. The position is still just an empty vessel, but that's going to change because instead of just creating a dump object, if we were to only create this, we could still use the interface because there's no logic inside of here. But we are going to put some logic inside of here, and this will be the logic for determining if a position is the same position. All right, so this will affect a lot of places because we use this a lot. Let's leave this for now. If we go into our position.ts, we create a function, samePosition, which will accept another position. So we say other position, which is of type position, and this will return a boolean, like so. We don't need to type in function. We can just write it like this. Okay, so this needs to return a boolean, and the boolean will be exactly the same as before, which is, let's go back to the constants, this one. We want to return this. So where did we have the position? Right here. Return this.x. So this keyword is used to reference the object that we are currently in. So we are right now inside of this position. So this will apply to this position. This.x and this.y would be equal to other position.x and other position.y, like so. All right. So now we have the logic for determining if a position is in the same position as another position, but instead of having it as a separate function, which you need to pass in two positions, we now have it as an extension or as a function on the position class. Okay, so save this up, refresh the page, it still works. We do see a lot of red lines. And we are getting the errors because we now expect that the positions are being created with two parameters that are passed in. And we also see on the right, property samePosition is missing in type XY number, but is required in type position. Right, so we don't want to define this function everywhere where we construct this, but what we do want to do is we want to use the constructor, so we instantiate the position with the values we provided, and then if we use the constructor, it will also generate this function for us by itself. Okay, so inside the constants right here, we get some errors for this piece, which has 0,7. Right now, we create a new position at 0,7. This piece has a position of 1,7. This will be a new position of 1,7. You see what we are doing? We are just using the constructors instead of just creating an object and then attaching it to a type. Let's see if we can also create or do some very performance good shortcuts right here. I'm going to select all the curly braces. So it's a lot of them. And we don't want to select the top one right here. So I'm just going to select them again. All the curly braces. Almost. Yeah, like so. We want to press backspace one time. and then we want to go to the right one time. Well, we want to press backspace once more and press delete. Then we say new position. We open up a parentheses, we press delete, and we press the right arrow key. We press the right arrow key again, delete, delete, delete. Then we press the right arrow key, and then delete and the right parentheses. All right, little shortcut. If you could follow along, congratulations. It feels really good, at least for me, to use those kind of shortcuts. It really helps cleaning up or doing big chunks of work at once, repetitive work. So if we save this up, those errors are gone, but we still have some inside of our chessboard right here. We are going to look at them and fix them. Instead of saying -1, -1, we assign it a new position of -1, -1. Right here we have the grab position. The grab position will be grab X and grab Y, like so. Then we can remove all this. Next up, down here we have a new position again. New position of X and Y, was it? Let's make sure. Yes, X and Y. Down here it is a new position of I and J. Yeah, I and J. So it's still going great right now. Right here we have a new position of I and J as well. Okay, nothing we cannot do. We can save this up and the chessboard has been fixed. Next up we have the referee. There are not so many references right here, which is easier for us to fix. So let's see, here we have destination at X, destination at Y minus path direction. Fine, new position with the X of destination at X and then the Y of destination dot Y. So you see, all we are doing is we are using the constructor. New position, and then an X of destination at X and a Y of destination dot Y. Let's save this up. And then we have the bishop and all the other rules. Well, frankly, the general rules doesn't use a new position. It's less that we need to fix. So you might ask, why didn't we immediately do it this way? Well, I have to say that's a very good question. Because this was the first time that we have created a chess game, we did not have a clear idea on what would be the best approach. As we have already done before in this series, is we have refactored code. All right, so the code that we created was not, I won't say the best code, but it wasn't the final code at least. So that's honestly, that's what we are doing right now. We are just refactoring code that we have created before with the knowledge that we have right now. And well, if we already knew how to create a chess game before we were going to do this, it would be a lot shorter and it might even be a lot easier. But by going through this thinking process and stumbling against, stumbling against problems is also very important for learning how to do new things or for learning things. So, well, you might think like, well, why didn't we do it before? Short answer is we didn't know what was the best approach. The long answer is the process is more important because that is where you are learning. if compared to the end result. Of course, the end result is also really important because that's what you are going to present. And well, it's really cool if it is looking great, but the process is really where you are learning new things and thinking like, okay, I can apply this in the next project that I'm going to make. Before we are going to move on, we are going to reduce the amount of code that we have right here by applying one little trick. And this trick is that we don't need to define that this is a position anymore. So like I said before, when we had interfaces and we used the curly braces annotation, which we have just deleted, the curly braces by itself don't say what type of object or what type of class they are. Now that we use a concrete class, we know that we have a position. So before, because we used the curly braces, which was actually an anonymous object, we needed to specify which object we were creating by saying, hey, this is a position. But right now, because we use the keyword new position, we call the constructor, we say we want a position. We don't need to say that this is of type position anymore, because if we hover over this, we see that it is of type position. So we can remove the types from all the places where we are assigning or creating a new position. So let's just say that colon position right here. We can remove this occurrence, this one as well, right here, here as well. So now that we have fixed every occurrence, we still see one occurrence right here, but well, we cannot remove it from here because we are not using a position constructor. We are just creating an empty array. If we remove this from here, it will say, hey, it's an array of anything. That's not bad, but we want to make sure that this will be an array of positions. So say, for example, if I say possible moves dot push a string, like view, then it will say, hey, string is not assignable to parameter of type position. But if we remove this, then it will be an array of anything. Then, well, we don't get the error because everything will be accepted. However, we do get an error because this function returns the position array. So, well, it's just better to be safe and write some extra code than to be sorry and to find out that the program isn't behaving as it should. All right, enough talking for now. I'm going to refactor the king, knight, pawn, queen, and rook rules in the same way that we just did with the bishop rules. If you'd like to follow along or do this yourself, again, feel free to do so. But know that you can also go to the GitHub page repository and copy over the code that we create in this video, because it might be a little bit tedious to do all those repetitive corrections. A little tip, if you're also manually doing this yourself, props to you by the way, select colon position is equal to and then the curly bracket or curly brace open. Then press Ctrl D a lot of times, so you select all of the occurrences. Then you can press delete, delete, delete is equal to new position, like so. Press delete one more time and open up a left parentheses. Then if we go on the end right here, it should only have the positions, I think. Yeah, I think that's right. So then we press Ctrl D a lot of times again, and then we remove the curly brace to the left with a parentheses left and a semicolon. And then the last thing that we're going to do is we are going to select the y, or the Greek y, and then we delete them like so. And if we save this up, we fix everything. Well, while we're at it, let's do the final one as well. So we select colon until the first opening brace. We say is equal to new position, opening parentheses, delete everything. Then right here, we remove the y, like so. Press backspace one more time. And then right here, the final statement. Oh, we have one space too much. So right here, the final statement will be a parentheses semicolon instead of a curly brace semicolon. So if we save this up and refresh the page, we see that it's still working. We can move the pieces. I'm glad that we can still move them. We can also move the enemy pieces. We can move the queens. We can move the king. Can we still en passant? We can still do that. All right. So it seems like it's still going great. That will be it for this episode. In the next part, we are also going to continue working on this object-oriented approach so that we end up with more clean code and also more intellectual entities. So right now, the position already has a function, samePosition, but we are not using it yet. That, with many other things, will be in the next episode. I want to thank you for watching. I hope you could follow along. Leave a like, comment down below, subscribe, and I'll see you in the next episode. Bye!